Hi everybody, it's Miss Austin and I'm going to go over how to graph from Vertex Form when that A value is not 1. And if you listened to the notes last week, we're going to keep using that pattern to do these graphs quickly without whoa, what is going on? This won't share my screen. Hang on, guys. What's going on? There we go. Okay, so here's the notes, and we're going to follow the same technique that we did last week. We're first going to find the vertex. So the vertex for this guy, it's been shifted 5 to the left and 4 down. So that's -5, 4. I'm going to go plot that. -5, 1, 2, 3, 4. If you like to draw the axis of symmetry in, you can do that right now. You could wait till after you get your extra points. It's up to you. All right, so that axis of symmetry is x equals -5. Hopefully you're picking up on that pattern. It's always the x coordinate. Okay, so normally our pattern is, I'm going to make a table. I don't want you thinking that these are the points. These are the patterns. So if you walk over 1, you walk up 1. I should say left or right. If you walk left or right 2, then you're supposed to walk up 4. That's because 1 squared is 1 and 2 squared is 4. But this time we have this new value right here. We've got a 2. So that means that our y is going to be 2 times as much. So over here, you're going to have to multiply everything in this column by 2. Okay, because if you imagine, if you plugged it in, if you plugged a 1 in to x squared, that'd be 1. But if there's a 2 in front, it'd be 1 times 2. Okay, so basically you're just going to multiply this by 2. And instead of going 2 to the right and left and up 4, you're going to go twice as much. It's going to be 8. And if you wanted to do the next one, it would be 3. Normally it's 3, 9. It'd be 318. We're not going to be able to fit that on here anyways. So now we can go plot our points. Okay, so we walk over 1. Normally we would just go 1, but it's twice as much. So it's 1, 2. Same to the other side. 1, 2. And then the next one, go back to the vertex, walk over 2. Normally if I square 2, I get 4. But there's a 2 in front, so it's twice as much. 1, 2, 3, 4, 5, 6, 7, 8. And I can kind of copy that over there. You'll notice this looks skinnier than the parabolas we were doing last week. Okay? An A value that's greater than 1 makes the quadratic skinnier or narrow. Okay. Okay. The domain, hopefully you've got that down. The domain is all reals. The range, the lowest I ever go is down here to -4, and it goes to infinity. Square bracket since I touched. All right. So basically, when A is not 1, whatever number is in front, you're going to multiply whatever these numbers are, which are 1 and 4, you're going to multiply those by whatever A is. If A is 2, you're going to multiply those by 2. If A is 3, you're going to multiply by 3. You're not going to change the X value. You're still going to plug a 1 in. You're still going to plug a 2 in. Okay, let's go try another one. All right, this time, let's just point it out ahead of time. I've got a half. Okay, so that's what I'm going to multiply those values by once we get to that point. So here we go. First, let's do our vertex. I'm going 6 to the right and 3 up. 6, 3. 6, 1, 2, 3. Okay, you can put your axis of symmetry in right now if you want. That's x equals 6. You can put this in right now, all reals. Okay, so normally my pattern is, I'm going to write that over here, 1, 1, 2, 4. And I don't want you to get confused. Those are not points. I'm not saying to go plot the point at 1, 1, and 2, 4. It's the pattern. Okay? But there's a half. So I'm going to have to multiply all of these by a half. And if you prefer, you could make a table out of it like this. So I'm not going to go 1. What's half of 1? Half. I'm not going to go up 4. What's half of 4? 2. All right, so let's go plot those. So normally I'm going to go 1, 1, but it says 1. No, you're only going half as much. So you're here at half. Same over here, 1 half. Normally you go 2, 4, but you're half as much. Half of 4 is 2. 2. And then if you wanted to do the other one, I mean, we can put it in there. Normally it's 3, 9, but we're going half as much. Half of 9 is 4 1/2. Just if you want. So 1, 2, 3, 1, 2, 3, 4 1/2. 1, 2, 3, 1, 2, 3, 4. You could also just reflect those points across the line or the axis of symmetry. Okay, you'll notice this is a little bit wider. So A values between 0 and 1 make your parabola wider than the parent function. Numbers greater than 1 make it skinnier. Numbers between 0 and 1 make it wider. A lot of students get confused and think a negative. A negative doesn't change if it's skinnier or wider. A negative reflects it upside down across the x-axis. Okay, range, the lowest this ever gets is 3 to infinity. Boom. All right. Okay, let's look at that A value. A is -3. So the negative means it's going to be opening downward, and the 3, that's what we're going to have to multiply our pattern by. So let's go start it off the way we always do. This means left 1 and up 8. So -1, 8. So -1, 8. Drawing that line of symmetry or axis of symmetry. X equals -1, domain, all reals. Okay, so normally my pattern is 1, 1, 2, 4. And I know this time I'm going down because there's a negative. Okay, but what's A? A is 3. So I'm going to have to multiply everything by 3, these. Okay, not these first two. So I'm going to walk 1, but I'm not going to go down 1. I'm going to go down 3. Okay, I'm going to walk over 2. I'm not going to go down 4. I'm going to go down 12. 3 times as much. Okay, let's go plot those. So normally I go 1, 1. I'm going down because it's a negative, but I'm 3 times as much. So it's 1, 1, 2, 3. Same over here. 1, 1, 2, 3. Back to the vertex. Normally it's 2, 4. 3 times as much. That's where I'm getting the 12. 1, 2, 3, 4, 5, 6, 7, 12. And you could just see how that's 2 away. You could copy that over there. And I don't think we could fit the other one. The next one would normally is 3, 9. It'd be 3 times as much. That'd be 327. There's not enough space on here for that. Oh. I'm just going to make those dots bigger so it looks like I'm doing a good job of hitting those. Okay, the range, this time the lowest is -infinity. You always got to put the lowest first, and it goes all the way up to 8. This time it has a max but no min because it's going forever and ever towards -infinity. All right, last one, here we go. What's that A value? The A value is -1/2. So it's upside down, but I'm only going to go half the distance when I'm moving in the Y direction. So let's do our vertex first. This is left 7, down 2, -7, -2, -7, -2. Oops, I didn't do it in red. I broke my streak. Axis of symmetry, x equals -7. Domain, all reals. Okay, normally the pattern is 1, 1, 2, 4. But A is a half. So I'll do this part in red. I have to multiply everything by a half. Right? So I'm still going to walk over 1, but I'm not going to go 1. What's half of 1? Half. I'm still going to walk over 2, but I'm not going to go 4. What's half of 4? 2. Okay, and these are not points. These are patterns. So now I'm going to go back. Don't forget it's upside down because of that negative. So I'm going to walk over 1, and it's half. 1 half. Back to the vertex. Over 2. Normally it's 4, but I'm only going half as much, so it's 2. And if you remember from that one up above, we could do the next one. It's 3, 9. But what's half of 9? 4 and a half. So 1, 2, 3, 1, 2, 3, 4. I mean, you've done enough with the other ones. It's just, what's that? 1, 2 and a half away. 1, 2. If you can fit more points, it just makes a more accurate graph. Be surprised even with 5 points. Okay, and my range, this time again, -infinity all the way up to -2. Never going to touch -infinity, touching on 2. I hope this helps with this week's activities, and I'll see you soon.